Welcome back to Do It Yourself Python series, and this is the part 3 on linear regression basics topic. And if you are here for the first time, um, please go ahead and watch my previous videos so that you can follow all the examples and the demos I'm showing as part of this session. In this session, I would like to cover a few concepts around machine learning model builder. This is from Microsoft. It's called ML.net. It is an open source and cross-platform machine learning framework. You can use this in Windows and Linux and also on Mac OS. And I'll show you a live example on that and how to use it. And I also wanted to cover some examples on linear regression using Python and Azure Data Studio Notebook. And once we have these examples and using the same data set from two different tools, and we want to compare those predictions and see how close they are and what is the basic difference between those models and the model creation concepts. ML.net is an open source and cross-platform machine learning framework from Microsoft. As you can see, this is now supported on Windows, Linux and Mac OS as of now. If you wanted to download this one, you can download it from Marketplace from the Visual Studio. And right now this is in a preview, so you can expect maybe some enhancements to this later this year. But go ahead and download it, and once you download it, it's very simple to install, and I'm assuming that you'll be able to download and install it, and once it is installed we can use that in the Visual Studio. The next step is to create a console C# application using Visual Studio. I'm using Visual Studio Community Edition. Create a new project, go to File, New and Project, and you can select this template here, console app, and then I'm using this .NET Core option here. So once you select that option and click Next and create this project, I'm naming this project as Pizzapy ML. This is for machine learning. You can name it any project name. After you create the project, if you go to the Solution Explorer, you should be able to see a solution and also an application inside the solution, Pizzapy ML. Right click on the project, and if you click on Add, and you should be able to see machine learning option here. This is basically to make sure that your installation is successful, and then it is available as an option here. So click on the machine learning, and you are presented with a couple of options here. Microsoft already included some templates to start with. If you are dealing with some text analysis, and if you want to apply some kind of sentiment analysis on that and predict any positive or negative outcomes from the text, and you can choose this template. And there's issue classification template and image classification template and price prediction. And there's also one template for custom scenario where you can build everything from scratch. So for this example, what I'm going to do is I'm going to use price prediction, even though I'm not really using any price related data, but I'm going to use that template because I'm trying to predict a numeric value. Okay, so click the price prediction template, and the next step, it is actually looking for the data, and the data can be supplied through a file, flat file, a CSv file, or the data can be queried from SQL Server. So the first part of this example, I'm going to use this file option and select the file, And I have already a sample file, CSv file, as part of the previous lab. So I'm going to select that one, and you can actually visualize the data within that file selection itself. So right now we have two columns in this file, weekday number and orders and some data, right? Just select that one, and immediately you should be able to see some rows under the data preview section. Right now it is showing 10 records out of the 50 rows, and also number of columns are 2 here. So the next option is column to predict. Even though I selected the price prediction model, I'm actually going to predict the number of orders based on a weekday number. So I'm going to select orders as my prediction, right? And then input columns, like you can just follow through these standard naming conventions, like you are trying to predict a label and using some features. I'm right now having only one feature left, which is nothing but one column left from this data set, but sometimes you may be dealing with multiple features as well. So it was already selected, so I'm going to leave it as it is. And next one is now we are going to train your model with the data set what we have, and unfortunately we don't know what exactly the regression model we are going to use here. So that is one thing which I wanted to really see in this model builder, but we don't have that option yet. So anyway, I'm going go ahead and I'm going to use this 10 seconds and start training. There are two important items you need to watch. One is that best quality, which is nothing but R squared value. As I explained in my previous videos, you will be mostly aiming for a perfect R squared value ranging from 0 to 1. 1 being the best model, means the accuracy will be more, and best algorithm. See, I don't have an option to select an algorithm which I like linear regression for this example, but right now it is showing that it is failed, and you can see why exactly it is failed with some error message here in this output window. So I'm going to increase this seconds to 20 and start training again. It looks like R squared value, I don't see any value between 0 and 1. So it looks like it was trying to apply this different models here, and then using the test data and also the train data to see which one actually fits the model and which one will give you the best score. But looks like we don't have a clear indication on what R squared value we will be using to evaluate this model. Even after training it for 30 seconds, I still have the same algorithm selected and with no specific number in the R squared area. Let's go ahead and evaluate this model. Because we only have one feature and we are trying to predict a number of orders, automatically this modeler will show you the number of arguments here. Let's enter something like 4 and try to predict. And if you are familiar with the CSv file I'm using in this example, it's using the multiple factor of 12 applied on that weekday number. So if the weekday number is 1 multiplied by 12, that is the value we have in the data set, and the same data set is repeated 7 times for every week. So now after the prediction is done, if I'm happy with this, then you click the code and you'll see one more option called add projects. Before you click on the add project, notice that there is only one project in the solution right now, which is console app. But if you go back to the builder and if you click this add projects, notice that it just added 2 projects in the same solution, and it is also showing you some samples or example code on how to use this model. And if you are more interested, you can go into this model project and you can go through this individual objects like model input. We have input as weekday number, and model output, right now we are only getting the score out of it. And if you go into this model builder class, and you can see on how all this code is set up and already hooked up for you. So this is a very simple and easy way to create a model using this model builder. But there are a few things we need to be aware of, that you don't have a real option to select all the different regression models you want, or you don't have a real control on the splitting the data and everything. And the next step, what I would like to do is that I'll go back to the scenario again. Instead of selecting this price prediction, and I'm going to select a custom scenario template this time. Select the same file, and the column which we want to predict is orders, and the feature we want to use to predict that is weekday number. So if you can imagine a scattered chart, the feature value will be in x-axis and the label value will be in y-axis. This time go to train again, but notice that now we have some options in the machine learning task drop down. You can select multi-class classification, binary classification, and regression. So I'm going to select regression here, and I know that the 10 second was not sufficient, so I'm going to go with 30 seconds this time. Click start training, and if you are interested, you can also watch all the activity here in this output window. Not a big difference, and same thing, and we got to know that it is using the same, it is actually advising us the same SDC regression here, and again there's no specific R value here, right? So let's go ahead and evaluate this model with the same number 4, the weekday number 4, and predict. And this time you notice that it is right now showing me around 48.5. The previous one was around, I think, 47.5 or something like that. So the idea behind this modeler is that you don't have to write any code, and we haven't even written any single line of code, but you can keep on running this train option and also evaluate to see whether you are getting your expected prediction or not. And again, once you are happy with this model and the prediction accuracy, and you can click on the code and add to the project, but this time it will not, because we already have the same projects added in the solution. all you have to do is delete these existing projects, and then you should be able to add a new one. So my observation on this ML.NET modeler, machine learning modeler, is it's very easy to use, and it is right now I'm using only in the Visual Studio. I haven't tried this on Linux, and I haven't tried this on Mac OS, but I think it should have the same interface. But it actually gives you an interesting insight on how these things can be modeled, right? Once the model, and you should be able to get the entire code, and you can actually dig into the code and see and how exactly these classes and also these methods are implemented. But this gives you a good idea, but few things it's lacking as of now, where you cannot actually select a specific regression method and run it, like in an iteration, or you don't have an option to slice the data as of now. So our next exercise is to use a notebook in Azure Data Studio and write Python code, access data from SQL Server, and run some linear regression and slice the data, and verify these R factors, and use the predict method to predict value. So let me explain what exactly I have in this notebook, and I also included a link here in this notebook, and this notebook will be published in the GitHub as well. Everything is same if you are following my previous videos, but in this exercise I'm using another module called ODBC, which is Python ODBC, and here I declared a connection string. This is my SQL Server. I'm using SQL Server 2019, and I'm using a trusted connection because both are running from the same machine. And I declared a connection variable here and initializing that variable by connecting to this SQL Server. Only thing you need to make sure is that you have this ODBC driver 13 installed on your machine. And just click here and see whether we are able to connect to the database or not. So right now it is showing ODBC is not defined. That's because straight away I actually ran this particular piece of code even before running this first section. So let me start with the first section. So that is successful, no errors, and no errors here. And when you click here, now you should be able to see the connection. The next part is that we are trying to get data from this Pizzapy database with some where clause here between 8 and 20, which indicates that I'm only interested in the data between 8 a.m. To 8 p.m. right? And this is select star from Pizzapy database. So let me run this query in SQL Server to make sure that we are able to see some data. This is my SQL Server Management Studio. As you can see, I'm using order 1 table, not the order table. Order table, I'm treating that as an OLTP table, and order 1 is just like an analytical base table. Once I get the data here, I know that it's right now getting around 27,937 rows. Going back to the notebook again, this time I'll try to run this section of the code, and there are no errors. So assuming that all the data what we are expecting is right now sitting in this data frame variable. And as I explained in the previous video, you can use this hist method to see the data distribution, and right now we have 3 columns, so we can see the distribution in all these 3 columns. Weekday number is pretty much straight, like from 1 to 7. There is no big distribution there. And order R is also very similar because they are like a standard values from 8 to 20, whereas the quantity has some kind of distribution. So where you can see this, it's going up and down here. It's always good to verify the data through this histogram, and it will give you some idea on what kind of data you're dealing with. If everything is flat, then you will not be able to predict anything. And also there is another method called on data frame called head. Using that, you should be able to pull first few records from the data set. This is to make sure that your data set is properly initialized with the column names what you wanted or what we have in the database. And I'm also using a scattered chart here using this. So this is a scatter chart for this RR and the quantity. And if you try to apply, a trend line with this kind of a scatter, well, maybe the trend line goes from 0 to 20 all the way, like so. You may have to really narrow this data down to a specific range so that you can actually come up with a proper trend line and come up with the proper R-squared value. And I'm using the same scatter chart, but this time I'm using weekday number and the quantity, and you can see this this is exactly the same, similar to what we are seeing by the order R and the quantity. And once you are familiar with this, or once you are comfortable with the data, and once you finish your skimming the data range, and create a model. So in this example, I'm using the same code which I used in the previous video, but I'm just initializing order R and the quantity. So this quantity is our label, order R is our feature, and I'm using this linear regression model here. R values are nothing but R-squared values, and I'm using K4. I'm using 2 splits and shuffle false. Splits is basically like you're trying to split the data set into smaller chunks so that you can iterate through and run the fit and score and then get the R value. So I'm using nsplits 2 and shuffle false, and this code is a for loop code. I'm having a train data and the test data. Train data is like a small amount of data. I'll be using it to train my model, and once I get the proper R-squared value on that, I'm going to use a bigger data set as my test data and run it against it and see whether those values are matching or not. This for loop is exactly doing that. Let's go ahead and run this. See, I have set values like 0.1 and 0.1. That means for 2 slices, 2 splits, I was able to get 2 different R-squared values. Let me change that into 4 splits. Run it again, and this time whatever the train data set it was able to pick up, and then test it on a different set of data. I was able to see 0.09 here, and 0.1 and 0.1 and 0.1. So most likely this is my model, even though I'm not really happy about this model because it's not even a 10% accuracy. But for this example, I'm going to go ahead and use this. It's a weekday number I'm trying to predict, and run this and see that it is actually getting 9. Let me go ahead and use this section of the code, whereas I'm trying to predict a quantity for the weekday number 4. So this is where I'm initializing 4 in an array variable, and I'm passing that array variable to this predict method on this model LR model. This LR model is what we created here. And finally, that model is actually storing all this fit and score results and R square values. So it is actually using that internally, that R square values on this weekday number, and it is trying to predict the quantity. If you click here, and right now we are seeing a value of 9.36. Again, quantity in our case is an integer, so I would say that this is 9. And keep this in mind, because we're going to go back to that ML.NET, that machine learning modeler, and try to achieve the same thing and see whether we are getting the same prediction or not. So going back to the Visual Studio, and I'm trying to use this machine learning modeler ML.NET again, but this time I'm going to use the data from the SQL Server, not from the flat file. So I'll go ahead and click this custom scenario. Instead of file, I'm going to use this SQL Server. This is my SQL Server name. And I'm using Microsoft SQL Server data provider. Select the Pizzapy database, and if you're not familiar with Pizzapy database, please go ahead and watch my previous video, and I have all the details, and you can get the script to create this database on your SQL Server. And it has insert scripts also, so it generates all the data you need for these examples. So I selected the Pizzapy database, and the table is order 1, always table. So that's, I think that's one dependency from the modeler perspective. And then the predict column, I'm going to select means a quantity as my predict column, because that's what we are trying to predict. But this time I see 3 features: order date, weekday number, and order hour. So anyway, I'm not really interested in this order date, because I don't want to give a date for the prediction, but I do have an option to select this the weekday number and the order hour. So I selected both columns, and you can verify the data here. When you click on the train now, and because I selected a custom template, I can select regression and multi-class classification or binary classification, but I'll still go ahead with the regression, and I'm going to use 60 seconds. And if you notice that there is no way you can split the entire data set, so the training is going by the number of seconds. I'm not sure what exactly it is performing behind the scenes, whether it is really splitting the data set or not, I'm not sure. So that's one missing feature here. But let's go ahead and click start training, and immediately, even the very first few seconds, see that it is trying to get the best R squared value. Right now it is at 5.3, which indicates that it is 53%. Looks like it is settled on this regression method. Let's go ahead and see the activity. So it is still trying to fit, and it is trying to score, and it's trying to get the best R squared value. And the only difference between this exercise and the one we saw on the notebook is in this example we are using 2 features, whereas in the notebook example we are using only 1 feature. And you can see that it is using this fast tree, and the R squared value is 2147, but whereas when it is using this a different regression, it is getting 5371, but looks like we have this 5396, and I think it's completed the 60-second training, and then it was able to figure out which is the best and the highest R squared value. So let's go ahead and use this one, evaluate. If you're not happy with that number, R squared value, and you can go ahead and try different options, running it, a different number of it means increase the number of seconds, and also change the features, or maybe limit the data set only within certain range, and you can do all those things. But remember that whatever changes you are doing to the data, the data needs to be in a table. So you need to create a table so that you can select it from this modeler. Let's see how evaluation of this model works. I think we were using a weekday number as 4, but we also have another feature here, because we selected 2 features, and which we don't have that in that notebook example. But anyway, I'm going to go ahead and see 14, use 14, which is 2 p.m. and click predict, and it is showing 8.6. I'm thinking that, from 8 to 20, it's morning 8 o'clock to evening 8 o'clock, this may be the average, or this may be the closest value. So this is 8.6 here, even though this is not exactly comparing apples to apple, but at least we get an idea that okay, it is giving us this 8.6, and maybe I'll go ahead and check with 8. Because we are not comparing apple to apples, what I would like to do here is try to change our modeling. I'll go back to this train scenario, data scenario, where I'm using this quantity that we know for sure that that's what we want to predict. But this time I'm trying to match the number of features and the column name also to the one we actually selected in the notebook. So that is a weekday number. So out of 3, I'm only selecting 1 feature, and then I'm going to go ahead and retrain this model again. This time 30 seconds, I'm using the same regression. Start training. And if you notice the activity here, most of the time we are saying the negative value, R squared value. It looks like that 30 seconds was not sufficient. But it's still finalized R squared value as 0, and 0 means it's like you can't really predict anything. So maybe I'll try to change this into a different machine learning method. I use this multi-class classification, but remember that we only have 1 feature. The accuracy seems to be around 10%. And if we go back and verify what we have on the notebook, we notice that if I'm using this order R, to change our model to match what we actually tested using the notebook, using Python, Here I wanted to select this quantity as my label, which is the value which I want to predict, and this time I'm going to select order R as my feature, only feature, and I'll go ahead and retrain this model again, select regression, and maybe I'll use 20 seconds, and it is trying to get the highest R squared value. In this case it is 5.4. It looks like it's around 50%, 54% I would say. And if you're more interested in how these models are selected, so it actually gives you a list of all the top 5 models it actually explored, and you look at this, out of this 5, there are 2 models which are giving like 5.4 as R squared value, which is close to 54%. So let's evaluate, and order R I'm going to select as 4. I think we don't have 4 because our store opens at 8 o'clock, so technically we don't have 4. So I'm going to go ahead and use 14 instead of 4, and click the predict value, and we have 8.52, and our overall accuracy is 54%. And because I'm using the same feature to predict the same label, let's go ahead and verify this with our notebook example. So let me rerun this one, and I'll have some values here, and then I'm going to use this 14 to match with what we actually tested using this machine learning modeler from ML.net. Click there, and we get around 8.06. We go back to Visual Studio, we're getting around 8.52. So even though we are trying to create models using different tools and different methodologies and different scenarios, like in the Python, when I'm using this linear regression, when I'm using the k-fold, I have an option to split the data set. That same thing is not available here. So we can't really say that it is apple to apple, but if you look at the models, the predictions are very close. So what you can do is that you can always use a different set of tools to try to model to work with the same data set, so that you can come up with the most viable model, and then you can use that to predict going forward. I hope these few examples gave you some good understanding on how to actually model and how to use those different regression methods, and how to split the data, and how to interpret this R squared value like from 0 to 1, and how to predict using that model, so that you'll actually get an idea on what the prediction looks like. But in both cases examples, we got the prediction as with the decimal places, but the quantity is an integer. So those kind of stuff you need to watch. But it's fun to create these models using different tools. And I always prefer notebook because you can execute all the code on the web page, and you can just publish the web page so that somebody can actually use that notebook and then execute all those statements with their own database. I hope this helps, and please take a minute to subscribe to my YouTube channel. Thank you for watching this video.